Okay, good evening. This is Professor David Delosreyes. Okay, this topic will be for those who are taking up SAT or CAT exam. Okay, just remember this one concept and you will not get lost in the so-called addition of fraction. The important thing here is the concept. Okay, just remember the concept and apply this in the addition of any fraction. Okay, and you can solve any fraction by doing this concept. Okay, let's proceed. How to add fractions? Uh, Example number one. 5 over 6 plus 7 over 8, and they should be equal to. The addition of fraction, it doesn't matter if the denominator are both equal or not, because by using this concept, okay, it could solve a problem for a fraction whether the denominators are equal or not. Okay, so this is a variable solution. So it doesn't matter if the denominators are equal or are the same or not equal. For the given example, 5 over 6 plus 7 over 8, obviously the denominators are different. And to add two fractions with different denominator, the concept is this. Just remember this one. To add two fractions, the denominator should be the same. Okay, the denominator should be the same. That's the only one you will remember. So try to convert to make the denominators of both the fractions to be equal. If we try to bring out the addition of this one by using this concept, remember this concept. No matter where you go, you will not get lost in the so-called addition of fraction. We will rewrite 5 over 6. Then we will rewrite 7 over 8. Okay? Think of a number, okay, in which if you try to multiply it to 5, 6, the denominator will become 48. Okay? So the only number that should be multiplied with 5, 6 is the ratio 8 over 8. Because the ratio 8 over 8 is actually 1. So it seems we are not changing the value of the fraction, right? Right? But to make the denominator of the 5 over 6 to be 48, we must have to multiply 5 over 6 by 8 over 8. For the second one, 7 over 8, think of a number in which if you try to multiply it to 7 over 8, the denominator will become 48. Okay, since this is 6, you should multiply 7 over 8 by the ratio 6 over 6. Because 6 over 6 is actually 1. This is 1. This is 1. So actually, we are not changing the value of the first fraction and the second fraction by multiplying the first one by 8 over 8 and multiplying the second one by 6 over 6. Okay? We are not changing the value of the fraction. But why do we do this? To make the denominator of both fractions equal. Right? So if we try to simplify this one, 5 times 8 will be 40. 6 times 8 will be 48. 7 times 6 will be 42. 8 times 6 will be 48. Okay? So the denominators now are actually the same. Okay? That's why we use the concept before adding them. Okay? The denominator should be the same. So this is a variable thing. It depends on what will be the number that you will place over here. So for any problem, this is a variable thing. I use your eyes. So 40 plus 42 will be 82. This is under same denominator, so this is all over 48. So this is actually 82. Divisible by 2, divided by 2, that will be 41. Divided by 2, that will be 24. So the answer will be 41 over 24. Okay? Let's try to check the validity of the answer. We use the calculator. 5 divided by 6 equals, plus open quantity, 7 divided by 8 equals, close quantity. The answer is 1.708. Okay, if you use the calculator, let's try to divide 41 over 24. It's the same, 1.708. But the proper way on how to add two fractions, okay, with different denominator or same denominator, because if the denominators are the same, it's an easy money, it's an easy problem, right? So you assume always that the denominators will be the same, the one that will be coming out from the SAT or CAT exam. Okay, and if that will be the case, this is the attack concept. This will be the attack that we'll be doing. You change first the denominators to be equal, okay, then you could proceed with addition. The addition is just that you add the numerators all over the common denominator. This is 48, is 48. So this is 40 plus 42, 82 over common denominator now, 48. So the answer will be 41 over 24. Okay, good evening from Los Angeles. Professor David J. De Los Reyes.